Hi, this tutorial is going to cover CCSP Domain 5. It is all about the cloud security operations, which covers day-to-day task activities that are necessary for you to protect the CIA triad of any cloud system and the data. So this domain is it covers the planning, designing, and implementation and operating your cloud's physical and logical infrastructure. Please subscribe to the channel if not yet done. So, how to build the physical and the logical infrastructure for the cloud environment? So we have different aspects here. The physical and the logical infrastructure that starts from the physical servers, racks, network equipments, and the storage to the logical infrastructure in the cloud as with the traditional IT infrastructure. But of course, the logical infrastructure makes it different in the cloud environment. There are a few factors that affects the data center design. For example, the locations, the legal and the legal jurisdiction and the regulatory requirements that will impact the data center design, the contingency, failover redundancy planning, and the compliance requirements in that particular region. The operational standards, for example, whether we need to meet the ISO 27001 or some other standards, physical and environmental designs. So for example, HAVOC, what is the temperature in that region? What kind of fire suppression system that is required? What kind of systems related to the HVAC, like for the temperature control, for fire suppression that are needed there in that region. So now it comes to the other aspects of the security when we build the physical and logical infrastructure. One is the hardware specific security configurations. So when we configure and deploy any hardware server, because it is true that underneath it is all the physical servers in the cloud service providers data center that are running. So it is equally important to make them secure, to make their security configurations more secure. So it starts from the BIOS, which is the um, which is the crucial part of any server, the basic input output system. It is the firmware that initializes and tests the computer hardware before booting the operating system. And it is very important to protect the BIOS, because if it is compromised, it is difficult to detect and will affect the overall infrastructure in the cloud. Also, it can impact um, the functioning and security of the hypervisor, the TPM, trusted platform module, and uh, it can also impact the virtualization. It can also impact the cloud service provider's responsibility, in terms of the overall responsibility. Then we have the TPM. The TPM is the mainly for storing the keys, for storing any sensitive information in the hardware, because this microcontroller actually is designed to provide the hardware based security. For example, if you have to encrypt the the data that is stored on a particular server, then what will happen is you need to have this you have these disks running on that particular server, and you need to have this TPM, which is actually storing that particular key, which is actually encrypting these disks and protecting that information. Then we have the storage controllers. So this storage controller is very important, because this is behaving like a gateway, and which manages and control the storage arrays. The virtually integrates the multiple physical storage unit into the single logical pool of storage, and dynamically this determines where to write and from where to read. It helps to encrypt the data at the controller level. So as I said, this behaves like a gateway, because it helps to encrypt the data at the controller level, which in turn, with the help of the inbuilt encryption functionality. We have the example of the storage controller, for example, the iSCSI. So this is just an example of the storage controller. Network controller. It is a centralized point of control that is used to configure, manage, and monitor physical and the virtual and network environment. Then we have the virtual hardware specific security configuration requirements. So starting from the hypervisor to the software defined network and everything in between, the virtualization are the core component of the cloud, because the virtualization management tools that are basically interface with the virtualized component and the underlying physical hardware to manage and to monitor. So the installation and the configuration of the management tool is very crucial activity. Uh, for that, you need to know your infrastructure, and in terms of the automation, the workload monitoring, optimization, that can only be achieved through the automation, because you cannot monitor your workloads manually. It is difficult because it is in the several thousands. How can you monitor those workloads? So it is very important to automate all these services, and more control, maybe applying least privilege principle there, and network isolation, role based access control, strong authentication. That is really needed there. Then we have the virtual hardware security configuration requirement. We have like the network, which is the physical security control, that are not just sufficient to protect the virtual resources. So in that case, we need more virtual resources to protect the virtual the virtual actual virtual resources. For example, the virtual firewall, we need the network IDS IPS to take the to detect and to react to any anomalies or any malicious activities on the network. For example, the logging system. And for storage, like storage, secure configuration of the virtual storage hardware, again, it starts from adhering to vendor specific recommendation and configuration guidelines. So whenever you are purchasing any hardware from the vendors, usually the security vendors, they are providing with the hardened configurations, but at the same time, they don't know in which environment you're going to deploy. So it is very important to follow the vendor recommendations for the security, and accordingly configure your resources so that you're not leaving anything open behind. Guest OS virtualization toolset. The virtualization environment can run any type of OS that provides a virtualization toolset, and the variety of the OS available to the cloud customer is limited mainly by the cloud provider and what they have configured. It is critical for the cloud service providers to configure guest OS toolset to expose only the supported platform which are intended to. And the security of this configuration is really important for the business aspect, because if it is not secure enough, then the customer can access all those OSs which you did not offer them free of cost. So it is important to protect them as well. So once you securely implement and build your physical and logical cloud environment, your attention must turn to the securely operating that environment throughout its life cycle. For example, the access control mechanisms, securing the physical and virtual network configurations, building and deploying the hardened OS baseline, and ensuring the availability of all the physical and virtual hosts and resources. The first item that is here is the configure access control for the local and remote access, because when it comes to the data centers, it is really important to configure the access control for local and remote, because you might be accessing the physical racks, you might be accessing those resources through ID rack, for example, remotely over the REST APIs to configure the servers and all. But whatever it is, for example, if it is, even if it is the local access through, let's say, um, through some means, there are different methods which can be used. For example, KVM, and we have, for example, console based, and then we have RDP. So it is important to save these, to secure these devices. For example, KVM, it is an input output device that allows a user to access and control the multiple computers from a single keyboard, video display, and the mouse, through the physical access. So if you have to configure the servers, if you have to make the changes in a particular server, having physical access to the rack in the data center, you may have this KVM on board, and consider the security of the KVM. For example, secure their interfaces, secure the firmware, so that it is not being misused to access that server which is not supposed to be accessed. Then the console based, every hypervisor offers the console based access to the to configure and manage the VMs, and the compromise of it can allow a malicious actor to achieve the dangerous level of controls. So monitor and audit the configurations regularly. Then we have RDP. So in RDP, we have the configuration of the client and server model, where RDP client is required on each node if you want to have access to the particular server through RDP. So it can be targeted through the man in the middle attack and the remote code execution, and there are various attacks on the RDP. So it is important to make it secure and keep monitoring. Secure network configuration. We have different things here. For example, we have the the VLAN, for example. The VLAN has to be this has to be secured. You know, this VLAN has to be implemented in a way so that we can segregate the network. We can isolate the network. That is the basic objective of the VLAN, having it in the logical or in the physical networks, means in the traditional IT or in the cloud. So the separate, for example, the separate development and the production networks. You may want to segregate one tenant from another tenant. You may want to distribute the network into the different zones, and remember from the exam point of view that the VLAN works at the layer 2. So then we have the TLS. Um, the TLS is basically to help at the data in the transition. When the data is being traveled from one server to another server, it is important to protect that channel using the TLS. DHCP, it is a protocol that assign and manages the IP address um, through it manages the IP address, subnet mask, and the other network parameters to each devices. Then we have DNS and DNSSEC as part of this. Um, so DNS and DNSSEC both are the integral part of the any internet or any cloud, because this DNS is a centralized naming system that translates the domain name, like website name, to their IP address. And hardening your DNS server is must, and DNSSEC is the technology that can help prevent the DNS hijacking or spoofing or the MITM attacks, because the DNS sec is an extension to the DNS, and the support the validation of the integrity of DNS data with the help of signature to validate the origin and the authority of that DNS server. Okay. Then we have the VPN there, which is again, if you want to access something um, uh, from your public network or from the home network, and you want to access the office network from there, then you have to create this private tunnel, and which makes it more secure to access your office network. That is the main use of this VPN. Then hardening the operating system through the application of the baseline. Creating and applying the baseline is the standard procedure for securing the OS in traditional IT and in cloud environment as well. Also, the OS baseline should be developed with the keeping the least privilege principle in the mind, and configured to allow only services, features, and access methods that are turned off, and disable any unnecessary services, close unused port, and disable the access routes that are not required on that OS. Then we have availability of the standalone host. These hosts are usually physical machines which are required to operate independently, usually in the traditional IT, but still used in the cloud as well. So there are modules in the AWS and GCP, which are offered as the dedicated host or the dedicated instance in the AWS, and also this standalone host is offered as the sole tenant node in the GCP, the cloud, Google Cloud. And we have then the next point for operating the physical and logical infrastructure is the availability of clustered host. So in terms of the clustered host, it is a group of the hosts that are physically or logically connected. The resources are pulled together. Every CSP offers some form of the clustered host when moving to cloud. From your exam point of view, you should know the difference between the standalone and the clustered host, because it will also help to meet the different SLAs with the customer. Distributed resource scheduling, DRS, that enables the clustered environment to automatically distribute the workloads across the physical host in the cluster. And we have a dynamic optimization that can optimize the resources in dynamic way. High availability, usually known as in security world as HA. There the customer expects their cloud services and workloads to be available whenever they need them. It is cloud service providers responsibility to make sure that that happens. Then we have manage the physical and logical infrastructure for cloud environment. So, to securely manage a cloud environment infrastructure, you must consider the remote access, OS baseline, patch management, performance and capacity monitoring, the network security, and the host of the other management actions. So, when it comes to the access control for the remote access, we need to have some sort of um controls there. The remote access to the cloud physical environment should be restricted to very few privileged CSPs, employees only, and must be protected with the TLS. And consider the multi-factor authentication for the remote access, that is very crucial. And common remote access methods may be like VPN, RDP, and secure shell. We discussed these methods. OS baseline compliance and monitoring and remediation. The baseline is really important for consistent and secure OS. The configuration management tools can help to automate, apply the pre-approved OS baseline. You can have a repository there. The pre-approved OS baseline images are kept, and you can apply it from there through the automation. Patch management, it is important for the patch management to first identify that what is the need of the patch. Do we have that patch available with the vendor, and then acquire that patch means download that patch from the supplier or the vendor, and then thoroughly test this patch, so that check the hashes to validate the integrity of the patch, and test the patch in the dev and test environment to avoid any risk in the production. Then it comes to the um, deployment. Deploy this patch in the production environment because you have already tested, and then validate. So what do you need to validate once the patch is already deployed in the cloud? So you need to ensure that everything is working fine in the production environment. Here, the automation is the key to apply such patches on the different workloads, on the different instances in the cloud environment in the production. Otherwise, it is not possible to timely apply these patches if you try to do that manually. So, what are the challenges in terms of the patch management? No standardization tool and processes to collaborate a lot. Thorough testing. Consider the time zone to apply on a multiple VMs in the different time zone. Performance and the capacity monitoring. The performance analysis and monitoring is important to meet the customer SLAs. For example, we need to take care of the network latencies, dropped packets, the other standard network performance metrics. Then we have compute for the CPU, for example, the excessive utilization and the response time. Then we have the disk here, the read write times and capacity limits. Then we have memory, for example, the excessive usage and capacity limits on these resources. Then we have the hardware monitoring. Let's not forget that we have physical resources running underneath, even in the cloud environment. So it is very important to monitor for CPU usage, fan speed, the temperature of the machine, the voltages that are coming in the data center or in the rack. So we need to keep them under the control. Configuring host and guest operating system backup and restore. Ensure that the backup and restore of the critical data and services. When it comes to the virtualization, we have few things to discuss further. For example, the snapshot of the VM. It is a copy of the VM. It's the virtual disk and any settings and any configuration. It is the the kind of stored in that with that VM snapshot. So what we have in terms of this, we have uh, snapshot, then we have agent based, then we have agentless. Okay, so in terms of the snapshot, it is a copy of the VM, and it's a virtual disk, and any setting and configurations associated with them, with that snapshot, it gets stored. With the agent based, this is the backup requires installing a component on each and every node, but doesn't manage well in the public cloud, because in public cloud we have lot of um, nodes there. While with the agentless, this requires a single agent to be installed on any given network rather than on each endpoint. So if we have different VLAN, if we have different subnets, then we just need to have one single agent on each network. So that this agentless backup requires the interaction directly with your hypervisor to snapshot and backup your VMs. Network security controls. This is the layered approach to the network security that relies on the several type of technologies, including the firewall, IDS, IPS. So, what is the firewall here? If we talk about the network security controls, the firewall is the main core topic and core network security control. It can be hardware based, it can be software based, it can basically what it does is the perimeter control and internal segmentation. So, monitor and control inbound and outbound traffic through the rules IDS, IPS, WAF, web based web application firewall. These are all next gen firewalls. IDS, it can be the signature based, where it will check for the particular signature of that particular vulnerability, anomaly, anything, any anomaly, unusual activity on the network. Is stateful, anything that is not part of the state or anything which is not part of the session is will be declared as the anomaly for that. An IDS is the network-based IDS that works in the promiscuous mode. HIDS, it takes the snapshot of existing file system and matches to the previous snapshot. That is host-based IDS. IPS is the prevention system control. So this is the superset. So always from exam point of view, just remember that IPS is the superset of IDS, because IPS by default includes the functionality of IDS there, because it needs to detect and then prevent. Then we have honeypots in the network security controls. The honeypots are typically designed to mirror your production environment. You can trap hackers to fake the fake environment and watch as they attempt to do the damage. Basically, the honeypots are used to learn the tricks and techniques which are being used by the hackers on their mirrored network or on their mirrored servers. Learn their strategy. Management plane, managing the physical and logical infrastructure of the cloud environment that requires the effective task and operations scheduling, efficient orchestration of the activities and resources, and comprehensive yet minimally disruptive maintenance. Implement the operational controls and the standards. So we have like the change management when it comes to the implementation in the operational control. Basically, we have many processes and policies that need to be managed here. ISO 20000 is one of the common standard, international standard, that is, international service management system, that defines the requirement for the service provider to plan, develop, and operate and improvements. And at the same time, the ITIL framework that establishes a set of detailed IT service management practices. So, if we come back to the change management, it is to create and implement a series of processes that allows the changes to the scope of a project to be formally introduced and approved. So every change management will have the changes to be requested first and then to be reviewed by the CCB, that is Change Control Board, and those changes have to be approved by the Change Control Board. Then after the approval, these changes will be implemented and then will be documented what was the change, why this change was applied, and what kind of versions which were applied. These changes can be anything. So like new purchase, deployment, upgrade, modify, hardware, software, decommissioning, changes in the data center that could be related to havoc, temperature, fire suppression, etc., modification in the IT manual. So any of these type of changes that can fall under the category of the change management. The continuity management, it helps to ensure that the CSP is able to recover and continue providing the services to its customers even amidst security incidents or during the time of crisis. But it involves the BIA process. So what is BIA? So BIA is the business impact analysis that has to be done first to arrive at the criticality of the resources. What could be the risk if these resources are not available? So that is the thing we need to perform to arrive at the proper management of the continuity. ISMS, Information Security Management, codifies the protection of your environment, confidentiality, integrity, and availability. And ISO 27000 is the standard for ISMS, which can be referred, and usually there are different vendors and customers who ask for the audits for the ISO 27001. Incident management. In terms of the incident management, it is the process of monitoring for responding to and minimizing the impact of incident, because An incident in any event that can lead to the disruption of the service provider's ability to provide its services to the customers. From exam point of view, remember that any incident management plan should be routinely tested and updated based on the lesson learned from the from the past incidents. um, how we identify the incidents, how we analyze, and how we correct them, how we can prevent them in the future is the key part of the incident management. Then we have problem management. It is the objective is to minimize the impact of that problem on the organization. Of course, there are few other aspects. For example, the problem is unknown cause of one or more the incidents, often identified as a result of the multiple similar results. Or it could be the non error that is identified the root cause of the problem. Also, it could be a workaround, that is a temporary way of overcoming um, the technical difficulties. Release and the deployment management, that is to plan, schedule, and manage the software releases through the different phases, including the testing in the development environment and the deployment after that in the production environment. So for CSP, the for the cloud service provider, the releases and the deployment management is very important in SaaS and PaaS service model, because IaaS, the infrastructure as a service, is not impacted because it is the purely the customer's responsibility. But in SaaS and PaaS, the CSP is providing the different software, different versions altogether. Configuration management includes the information about the physical and logical components with the cloud environment, including settings, versions, patches, and levels. Service level management, it has involves the negotiating, developing, and managing all CSP SLAs, contracts, and the operational level of agreements. So it is important to review these, what is there in SLA, what is there in contract, and how much operational level of agreement that we have that we need to provide to the customers. Availability management involves the establishing your system's availability objectives, for example SLA, for example monitoring, measuring, and evaluating your performance against those objectives. If you have a contract, for example, and if you have guaranteed that 7 nines or 5 nines or 9 nines the service availability, you need to manage that availability. You need to have plan for that. Capacity management is the process for ensuring that the required resources capacity exists all at all time to or exceed the business and the customer needs. Digital forensics, the data acquisition and the collection, this need to be planned. We need to have a proper plan for how to collect the data, what will be the jurisdiction, how to collect from that location, and things like that. And then we acquire the data, what will be the acquisition strategy. For example, if the data is in the non-volatile memory, if the data is on a certain hard drive, which is for example the data is available in the different region, then how to acquire that. And after all, we need to verify that data integrity. We need to maintain the properly that integrity of that. So all in all, in the forensics, it is important for the recovery, preservation, and the analysis of the digital evidences that are associated with any cybercrime and the computer incidents. Basically, any forensic is intersects with the law, technology, and the scientific methods, of course. Uh, when it comes to the collecting, acquiring, and preserving the digital evidences, means the collection means identifying, labeling, recording, and acquiring the data from a possible source of relevant data. Then we examine that processing the collected data, and then we analyze that, analyzing the results of that examination, and then we prepare the report for the presentation purpose. Then we have the evidence management. So this is the chain of custody from the evidence collection to the trial. Because the moment you collect the evidence till it is presented in the court for the trial, it has to be maintained for the chain of the custody. That is the most important part of any digital forensic investigation. So the cloud provider must maintain the well documented policies and procedures for the evidences and management. Policies should establish that what type of the data to collect and how to properly engage with the customer authorities and the other stakeholders. Managing the communication with the relevant parties. Basically, these are the vendors, who are your vendors, who are your customers, who are your partners, and who are your regulators. Need to identify those. What will be the target of communication? What will be the objective of communication? What will be the media to transmit the information or to exchange the information? So all these things will need to be identified initially. When you know when we talk about the vendor and the partners, so in both these cases it is really important to properly onboard them, and then properly manage the vendors and partners till we off board. For example, you are having your vendor for the data center, for example, the AMC for your servers. So you need to onboard somebody that you need to establish some kind of accesses for them. You need to establish some more stuff for these vendors and partners, proper agreement, a proper legal agreement, so that if any breach or anything, any theft just because of those employees, their employees, the vendors and partners employees, what can be done. So onboarding has to be done on that. And the manage both the vendors and partners, regularly monitor and regularly audit their accesses and everything, and the legal contracts, etc., until you offboard all those vendors and partners. Keep that up to date. Okay. Similarly, we have the regulators, like early communication with the regulator is very important while setting the cloud, and the infrastructure should be compliant with all the regulations. And also, if there is any other stakeholder, we need to identify that as well. Security operations, it includes all the tools and processes and the personals required to accomplish that goal. So, Security Operations Center, it is a very important activity for the security operation. It is a centralized location where the designated information security personnel continuously monitor and analyze any organization's security posture, and also responsible for ongoing and operational security. They are staffed 24 by 7. Teams are responsible for detecting and reporting and responding to the security incidents. Also, the virtual SOC allows the team in the different locations to share the resources and communicate in the real time in order to monitor and respond to the security issues. Monitoring of the security controls. We discussed in the previous slides that what kind of security controls, for example, the firewall, different firewall on the network, and the other monitoring tools that we need to have in place in the security operations. Log and capture and log capture and analysis partners. SIEM, the security information and the event management, is the important tool for this activity, because on we have some critical servers and critical machines running, critical functionalities running. So anywhere, whenever the event is generated, that event is supposed to be sent to this centralized SOC, where we have SIEM in place, and SIEM will be aggregating those logs, because you might have such logs from two different services. So it is important to aggregate those, and we need to manage these logs on the SIEM, starting from, for example, the storage, uh, rotation of those logs, retention of those logs, maintain integrity, and how to verify. So it is important to maintain the integrity as well, because if at the later stage, if those logs has to be presented somewhere, so there has to be some way to verify these logs, whether these logs are tampered or not. Incident management is the process of monitoring for responding to and minimizing the impact of the incidents. So we discussed that in just in the previous slide. With this slide, we conclude the domain 5. I hope you like the video. Thank you for watching. Thank you. Please subscribe if not yet done.